We're in final stages of development of this new part for our sort of next generation electric Land Rovers. And I want to show you how we're turning what was an old hand throttle into a gear selector, a drive selector. The first step in this process is always a sketch. A few other angles, all in our engineering wiki here, the final graphics for those gauges. And then importantly, that sketching and that discussion turns into a 3D model. A recreation of the original that we can then split apart and send off to laser cutting and then bend and fold appropriately with, of course, all the cutouts for the lighting, the mounts for the PCB. So if you imagine, you've obviously got your foot pedal, your accelerator, throttle pedal. That's also connected to this. And basically this set the minimum, the idle speed, and you could use that because your Land Rover was sometimes a tractor or a generator almost running other devices off it, or it was wanting to toddle along as a little tractor, kind of like a boat, where you set the hand throttle. It was also a really, really dangerous cruise control if you wanted to use that on the highway. And so we've been working hard to recreate that essentially as a drive selector. So park, reverse, neutral, and drive. And we're able to, change it from being little tiny notches to something that allows you to have, do simple things like a 3-point turn, quickly reverse to drive without accidentally going into park, figuring out all these things, but recreating the raw sort of sheet metal of it. Some big stuff that we've been working through is how that actually translates into controls and digital signals. Thinking about, in particular, the error handling of this, because the drive direction of the car is obviously critical, and so how we use the LEDs to indicate a correct shift, because you've also got to put your foot on the brake to change directions and integrate with the park brake and all of those kinds of things. A big thing was reliability. This is going to have hundreds, if not thousands of movements over the course of its life, separating things like the movement and the pivot point of this lever and giving that a spring action and everything, and having that have nothing to do with the signal. So this isn't a potentiometer or anything like that. What's actually happening to control this is on the underside of this is a magnet, and these sensors you can see across here sense the presence of that magnetic field. So it's kind of it's a foolproof mechanism in that the magnet can only be in one place at a time. But it's also something that we can, once this is the final printed board, we can fully pot, meaning we can basically coat it in a resin, create something that is completely waterproof, cannot vibrate, is almost, indestructible. This will have a cover plate too. And this can work essentially with no moving parts apart from this big mechanical pivot forever.